Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, welcome back. I hope you're well. In this episode, we're going to carry on talking about a few definitions related to organic chemistry mechanisms. In the last episode, we talked about what is a mechanism, and we also talked about what is an electrophile and what is a nucleophile. And I also mentioned about the arrows that show movement of electrons, and we're going to talk about that a bit more today. So these are frequently called curly arrows, and this is where we see or draw a curved arrow on the structures of compounds and trying to describe what's happening during a reaction mechanism. So firstly, let's tackle why are they curly arrows? Why do we have this curve? Well, I don't know if this is the actual reason, but one thing it does is it stops us getting confused. It stops the possibility of confusion between these arrows and the normal arrows that are going from reactant to product or reactant to intermediate to product. In other words, it prevents us getting confused between these arrows and the arrows that separate stages of the reaction rather than things that are happening within the reaction. Okay, and what are we showing with these arrows? The arrows are usually showing movement of a pair of electrons. We'll talk about an exception later on, but usually it's a pair of electrons. So the arrow starts, the base of it, if you will, where the electrons are moving from, and it finishes where the electrons are moving to. And it's really important to be very specific about the start and finishing position of an arrow, because you're showing where the electrons are moving from and to. And unless you get lucky and just pick the right spot by accident, you're not going to get the marks at all. So movement of a pair of electrons could be a bond breaking, or it could be a new bond forming. That could be from a lone pair, for example. So if we're forming a new bond from a lone pair to an electrophile, so for example, the nitrogen on ammonia is forming an extra bond to an H plus ion that's nearby. The beginning of the arrow is by the lone pair on the nitrogen, because that is where the electrons that are going to form the bond are initially located. The end of the arrow, where the arrow head is, going to be directly in the space between the nitrogen and the H plus ion, ideally about halfway between, because that is showing where the electrons are ending. Not ending on the H plus, the electrons are not being donated to the H plus and that's it. They're forming a new bond between the nitrogen and the hydrogen, hence the electrons are going between the nitrogen and the hydrogen. Okay, how about a bond breaking? Well, in this case, our arrow will start over roughly the center of the bond, and the end of the arrow will show where the electrons are moving to, and that's usually one or other of the atoms that is in that bond. And we did mention there's a possibility of arrows not showing two electrons. This is where we get homolytic cleavage or homolytic breaking of a bond. And a good example of this is when UV light causes the cleavage of a chlorine to chlorine bond in Cl2. The result of that is that one electron from the chlorine to chlorine bond will end up on one of the atoms and one electron will end up on the other atom. So that you will in fact see two arrows, both starting at the center of the chlorine to chlorine bond. One will go towards one chlorine and one will curve towards the other chlorine. And both of the arrows will have a single arrowhead, not the full point. Each will have a half arrowhead, if you will, to indicate only one electron has made that move to that chlorine. Of course, that's why there needs to be two arrows, because there's an electron gone to each chlorine, and we do need to show that. The result of that, of course, is two chlorine atoms or two chlorine free radicals. Okay, I hope that's been useful. If you'd like to get in touch with me to suggest some more chemical words that you'd like to hear a nice, crisp, down-to-earth explanation for, then please do contact me on my Instagram. It's at Chemistry Made Simple. I really look forward to hearing from you. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry-made-simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.